So our last example for the day is example 4a that we're going to do together. And that is extra special. And the reason I would say that is because it's the most unique of any equation that you've written, whether it's either for ellipse or for hyperbola. And here's why. We have never had the word asymptote in our ellipse equations, okay, from our first week, because they don't have asymptotes. So asymptotes only apply to hyperbolas, and since they only apply to hyperbolas, this is our first exposure to using that information. But the great news is when you're given the asymptote, and when Miss Olson gives it to you using the point slope form that she's encouraging you to use because it's so much easier, we can immediately identify the center. Because if you're using both equations in one, the plus or minus, then this ordered pair, the only ordered pair that both equations go through, is the center. And so you know that it's 9 and 5. Negative 5. Now, when you're making that decision, you want to make sure, though, that you remember to put the x first and not just go in the order that you read left to right. So there's our center. We know that we also have encouraged people to write down A and B and C, so I'll leave space for that. We could consider whether or not we're going to need this relationship. We'll come back to whether or not we do or don't in a moment, but it's there if we need it. I am going to draw a little sketch here because I do find that personally helpful. So what I want to recognize is that I have a point at 9, negative 5, which would be, somewhere over here in quadrant 4. Okay, can label it. And that's my center. And it's between 9, 9, that's up here, and 9, negative 19. So again, you'll see the fact that the y values were, we could always check our work. So from 9 to negative 19 is 28. If you cut 28 in half, you move 14. 9 minus 14 is negative 5. Negative 19 plus 14, since you're moving up, is negative 5. So that just kind of confirms my center. Okay? But the bigger piece of what it just told me is by identifying this to be the center and this to be the vertex and figuring out that 14, I now know my A value. Okay, and that's quite helpful. Now, what I want to remind you of is this is also showing you the orientation. Since the vertices are oriented above one another, that's going to make this a vertical hyperbola. And if it's a vertical hyperbola, then this is our rise. Okay? And so we have a rise of 14, so I want you to think about slope for a second. You know that slope is going to be rise over run. And you just figured out that the rise in the guide box is going to go from the center to the top, that's 14. So now we want to figure out how far over it goes. So the one thing I noticed, though, is I already have a slope. And that's 7 over 5. So what I want to kind of recognize is if I took this 7 over 5, and I recognized that eventually this slope that I was working on, that I was partway through when I paused, is 14 over something, I'm pretty sure you guys can see the relationship from 14 to 7 and work backwards. What number would give me the same relationship? Well, it's clearly the value of 10, right? So if I take 14 divided by 2 is 7, what number divided by 2 is 5? And that run is my B value. Now, although I wrote all this stuff down about C, the question is, do I need it? And I would argue you don't. You know your center, right? We've identified that. We know our A, we know our B, and that's all we need. So we can come together. Keep in mind it's vertical. If it's vertical, you have to make sure that you start with the Y. Use your subtraction. I like to finish my center first. Make sure that you don't forget the equals 1, even if you run out of space. We know a squared is first, so if you need to use your calculator to figure out where I got the 196 from, you're welcome to do so. And then we'll do b squared, so 10 squared is 100. And our last step, as we hopefully know, because it's our fourth example, is that Miss Olson expects you to identify easily what that answer is by putting an answer box around it. Now that's your last example for the day in terms of videos. I will be posting the evens as written examples on the inked notes. You are welcome to ask for an additional video if you find that you need it or some extra explanation, but I will keep the videos kind of more manageable as you start the assignment. Have a great day.